Hi everyone, Mr. Mark here. In today's video, I'm going to be going through a couple of examples involving superannuation. Now, this is from the textbook. It says superannuation is a long-term saving plan that helps people save for retirement. Now, it's got in here that in Australia, your employer must pay an extra 9.5% of your income as superannuation, and that sort of goes towards a fund that you can access when you retire. However, that since has changed. It is currently, as I make this video, 11%. It will go up quite shortly to 12%. But for the sake of this video, we're just going to use 9.5%. But yeah, if you're got a different value there, then probably that's why it might be 11 or 12%. Or if you're watching in a different country, hello, it may be completely different altogether. So let's look at the first example here, example 24. Dean is 20 years old. He's starting full-time work at a department store and will earn $52,000 per annum or per year. Dean's employer will make quarterly contributions to his super fund. How much will the employer contribute to Dean's superannuation fund each quarter? So he's going to be paying 9.5% of $52,000 every year. And to work out per quarter, we're going to divide that amount by 4. So it really is as simple as working out 9.5% of $52,000. So 52,000 times by, mathematically, of is to multiply. 9.5% will be 0.095. Okay, so that's how I calculate 9% of $52,000. And then I'm going to divide that amount by, excuse the line, 4 to determine the answer to question A. So on my graphics calculator, I'm going to head in just to the run function to do this one. And we've got 52,000, keep it like that, 52,000 times by 0.095, all divided by 4, which will mean that Dean's employer will contribute $1,235 every quarter into that super fund. Okay, so $1,235 is the answer to question A. Now, the second part here says Dean's superannuation fund returns 5% per annum or per year, compounded quarterly. Find the amount of money in the fund when Dean retires at age 60. Give your answer to 3 significant figures. So there's a lot happening in that question, but we are going to be using the compound interest section on our graphics calculator to solve this. First of all, this is going to be how much is paid per quarter. But before we even use that or put that value in, we need to, again, if you're using that graphics calculator, put in some values for all of these variables within that compound interest section. Okay. And of course, first of all, being the number of periods. Okay, so how many years, first of all? If Dean's 20 and he's going to retire at the age of 60, we're talking about 40 years. Okay, so for B, the value of N is going to be 40 times by how often it's compounded per year. In this case, it's quarterly. So 40 times 4, it's going to be my value of N, or 160. The value of I, the interest rate, again, put this in as a number, as a percentage, not as a decimal. It's 5%. The present value, it's got. Let's imagine he doesn't have any money in his super account to start with. I mean, that could be a limitation to this question. He may have had a job before he started at the department store, but anyway, let's assume that there's no money in his super fund to start with. The PMT, the amount that's going to be paid into that account every quarter is $1,000 or $1,235. So we're putting that as a negative value, remember, because it's being paid in. The future value is kind of what we're asking it to determine for us, and it's going to be rounded to 3 significant figures. PY and CY in this case will both be 4 because of being compounded quarterly. Okay, so that's why those values are both 4. So I'm just going to put that into the graphics calculator and ask it to determine the future value for me. Essentially, that's it. So graphics calculator, N is 40 times 4. or 160. I is 5%. Present value is going to remain 0. PMT is the amount that's being put into that account every quarter, so $1,235. We calculated that in Part A. The future value is what we're actually trying to work out. So PY and CY will both be 4 because it is compounded quarterly. So what is the future value? Let's ask it to determine that for us. So what this says is that when Dean retires, he's likely to have $622,244.46 approximately in his account. Now it's asking us to round a 3 significant figures. So we're actually going to round it to $622,000. Okay, so the future value is approximately $622,000. So that's it. That's how you determine superannuation based on all those things. Keep in mind with this one, there are a few limitations. We haven't considered tax. We haven't considered the fact that Dean's only 20 and that's what he's earning now. He may get is more than likely to get a pay rise due to inflation and indexation of wages. He's also likely to get a promotion and get paid even more as well. So that amount may increase. Not even taking into consideration that 9.5% has increased over the course of the last few years anyway. So there is a few limitations, but based on that, okay, that is the answer to the question. But there's a little bit of information around some limitations to that solution right there in case of that example. All right. Next thing I want to talk about is when we're withdrawing our super. So again, straight from the textbook, once you retire, you can access the money in your superannuation fund to spend in your retirement. Most people, again, will take a little bit out at a time rather than taking it out in a lump sum. So we are it says here, we are now taking money from the account rather than depositing into the account. So the value of PMT entry is going to be a positive amount now, okay? Because we're taking it out of that account, it becomes positive. So this example here says, and I have sort of got a little bit organized already. Heather's just retired at age 65. She has $900,000 in a superannuation fund. She rolls over the money into a pension fund which returns 4% per annum compounded monthly. If Heather withdraws $5,400 per month to live on, how long will it take for the money in the fund to run out? Okay, so how long will that $900,000 last her if she withdraws $5,400 every month? Okay, the 12 there, and it is 4%. It's in an account that pays 4% per annum, compounded monthly. So basically, we're going to try and work out is how many months will that $900,000 last Heather. So in our graphics calculator, we're going to put in these values here, asking it to calculate N for us. So let's go back out. N now is what we're trying to calculate. So let's just set it as 0 for now. The interest rate here is 4%. Sorry. So that's 4%. Present value is the $9,000 that is in the account. Sorry, $900,000, bit of a difference there. PMT is the amount that she's withdrawing every month to live. She no longer earns a wage, so she needs to withdraw money from her super fund. So that's $5,400. Again, notice that's a positive amount. When does the account basically equal 0? When does the money run out? That's what we're asking for. How long will it take? PY and CY, again, in this case, are both 12 because there is still some interest being earned on the money that's in there. That's 4% per annum compounded monthly. So let's go ahead and ask the calculator to tell us how many months will that money last. So calculate the value of N for us. So it tells us that the answer is 243.68 months. Look, let's go ahead and round that to 244 months. So N equals 244. In this case, N is months because we are compounding monthly from the question. So it's probably more appropriate to give our answer in in years. So we could divide 244 by 12. Okay, so good way of doing that. Or just one thing I'll point out when I do this. So 244 divided by 12 will tell us how many years. It's 20.33 years, or in this case, it's actually quite nice because it's 20 years and a third. So 20 years, or 20 and a third years. But how many months is that? Let's be really specific. Okay, so 20 years and 4 months is a third of a year. But how do you determine that from the 0.33? We would do 12 times by the decimal values there, 0.33333 recurring, which gives us approximately 4 months. Okay, strange. If I've got to put another couple of threes in there, hopefully that sees now. There we go. Good. So 4 months. So it will last her 20 years and 4 months. So it will last her until she is about 85 years, based on her retiring at the age 65. Question B, though, says if Heather wants the money to last until she's 90 years old, how much can she afford to withdraw each month? Okay, so she's going to have to decrease her spending a little bit. Okay, so she's not going to be able to take out that much every month if she wants that money to last until she's 90. So how much can she take out? So here we're going to actually ask it, what will the PMT value be based on pretty much everything else remaining the same, except we are going to put in an N value. So N will now need to be, first of all, how many years? So if she wants it to last from 65 to the age of 90, that is the difference between 90 and 65, which is 25 years. And we're going to multiply that by 12, obviously, because 12 being how often the interest is compounded and how often she's withdrawing a certain amount of money. The interest rate will be, again, 4%. The present value she starts with at age 65, retirement age, is as above, $900,000. PMT is now what we're actually asking it to work out for us. How much can she afford to withdraw if she wants it to last that long? Again, we're going to drain that super fund to $0, and PY and CY will again be 12 based on being compounded monthly. So we're going to just change a few things. We're not going to change much in the compound interest function here. All we're now doing is changing the number of years, the number of periods, to 25 times by 12, and asking it to work out the value of PMT. So I don't even have to change it to 0. I can actually say, what would the PMT value be? It is telling me that she can afford to withdraw $4,750.53 per month for 25 years in order for that money to last until she is 90 years old. So the answer is $4,750.53. $4,750.53. Again, you know, there are a few things that we're assuming here. We're assuming that that interest rate doesn't change over the course of those 25 years. But again, with the information we have based on this question, that is the solution. That's how much she can afford to take out per month to make it last until she's 90. Anyway, again, another couple of simple examples, this time on superannuation. Look, if you've got any questions, please drop them in the comment section. And if you are watching from a different country, perhaps put that in the comment section as well. I'd be interested to know where you're watching from. Anyway, see you next time.